Hello, everybody. So today I'm going to go over the assignments from the previous video. I noticed a lot of errors. Most of them actually were just careless because you're skipping steps. It is so important to crawl before you walk and you walk before you run because every time you skip steps and you're a baby and all of a sudden you're running, you're going to fall and you're going to fall hard, assuming you can run. So make sure in mathematics, if you want to do well, you really need to show your work, okay? So I had two set of problems. One dealt with one die and the other one dealt with two dice. And we assumed that they were fair die or dice. In other words, they're not loaded. The center of gravity is literally somewhere in here. So that's 1 and 2 and 3 and 4 and 5 and 6 all have an equal chance of being selected. There are ways, by the way, to chemically move the center of gravity from here, which is halfway between this face and that face, and halfway between this face and this face, and halfway between the up front face and the back face, literally like in the dead center of a big classroom. You can move it further away from the center. It's called the center of gravity. This way, this face will have more chance, and this one will have more chance of being picked if it is in this region. And therefore, the probabilities are not going to be 1/6 each. Makes sense? So that's why we use the word fair die or unloaded die. So the first one was really simple. If you just follow the simple rule, you had a die, you roll a die that is fair, and you were asked to find the probability of getting a 6, probability of getting a 5 or a 6, probability of getting a number less or equal to 2, and then finally the probability of getting a 2 and a 3, okay? So to get a 6th, there is only one of them out of my sample space options, and there are 6 of them, right? 1, 2, 3, 4, 5, 6. The sample space is composed of 6 options, and to get this 6, there is only one chance, so it's 1 out of 6 chances, okay? I don't know if I did this correctly. I think it's 16.6 bar percent. Now, probability of getting a 5 or a 6. Now, by definition, probability of getting A, put it in blue, probability of getting A or B is the probability of getting A plus the probability of getting B minus the probability of getting A and B. Okay? That is by definition, right? Well, if I just follow this rule, I'm going to have to say it's the probability of getting a 5 plus the probability of getting a 6 minus the probability of getting 5 and a 6. Now, clearly you cannot get 5 and a 6 at the same time. There is only one die, right? So this probability is 0. So that leaves me with 1/6 chance of getting a 5 and 1/6 chance of getting a 6, okay? If I have to put a Venn diagram on this one, it's going to look like this. They don't intersect. You cannot be a 5 and a 6 at the same time. You cannot be even and odd at the same time. So we call these mutually exclusive. They don't intersect. Okay, they don't intersect. So if they don't intersect, the intersection, the end parts is non-existent, okay? And that's why the probability of getting a 5 and a 6 is just nothing. It's 0, okay? So the answer is, 1/3. It's not 33, by the way, 0.3%. It's 33.3 bar percent. Because 33.3 is different from 33.3 bar. This one is 33.333 infinitely many threes. This one is 33.3000000. So it's not correct to say 33.3. So I would say 33.3 bar, or just leave it as 1/3, okay? All right, moving along. What's the chance of getting a number less than 2? Well, you can either get a 1 or a 2. Now, if I had strictly less than 2, then you just pick 1. But I wrote x less or equal to 2. That means you can either get a 1 or get a 2. And you know what or means. You add, get in a 1, plus get in a 2, minus get in 1 and 2, which is impossible. So that's why I only wrote those two. Okay, so 1/6 plus 1/6 is 1/3 again. Okay, the last one, maybe I should have put it before this one. What's the probability of getting a 2 and a 3 at the same time? Well, that's impossible, because 2 and 3, they look like this. There is no intersection. They don't intersect. You can't have 2 or 3 here at all. Okay, 2 cannot be 3. All right, so that's the first question. Second question, which is a little harder, but surprisingly, most of you had trouble. That's the funny part about teaching. Most of you had trouble with the easy problem. And you did not have much of a problem with the second problem, which I think is much harder, okay? Which only tells me that this has nothing to do with intelligence. It has something to do with not showing the steps, not showing the sample space initially, and not writing all the steps. All right, I am going to organize your second problem in a table. And this is the reason why I want to go over the homework, because I want to show you a nice trick. Okay, so don't look here yet, okay? I have 2 dice. I'm rolling 2 dice at the same time. They are fair. They're numbered 1 through 6, both of them, okay? What is my sample space? Well, my sample space, as I said on the video, the previous video, is not numbers like these, but they are pairs, because the first number deals with the first die and the second number deals with the second die. So they start with 1, 1, and I'm just putting them in order. 1, 1, 1, 2, 1, 3, 1, 4, 1, 5, 1, 6. Once you finish with the 1 as your x value, you move to 2. So 2, 1, 2, 2, 2, 3, 2, 4, 2, 5, 2, 6, and then 3, 1, 3, 2, 3, 4, all the way to 6, 6. So I assume you can tell that there are 36 options. I didn't list all of them. I just showed you how it works, and I jumped with 3 dots. In mathematics, when you put in 3 dots, it means and so on, okay? And I put the last one. And I'm going to write them here anyway for you. So this is your sample space. You have 36 options. So the question is, what's the probability of getting a 3, 3? Basically 3 for x, or for the first die, and 3 for the second die. I'm sure all of you could guess there is only one option out of 36, okay? But these get a little tricky. So what I decided to do is create a table. These rows represents die 1, die x, and these columns, these numbers are representing die 2, die y, sorry. And so I put the pairs. So this is your x, this is your y, this is your x, this is your y, this is your x, this is your y, this is your x, this is your y. That's why I put 3, 4, right? So I just listed all of them. That is your sample space, by the way. And if you count them, you're going to see 36. That is 6 by 6. That's 36 pairs. 36 pairs. Why do I do this? Because this provides me with a visual on how to do these problems or any problem that is even harder, as I'm going to give you next, okay? So what's the chance of getting a 3, 3? Notice that 3, 3 shows up only once. Now, if I had said, what's the chance of getting a 2 and a 3, without telling you the order, well, there is a 2, 3, but there is also 3, 2, right? So be careful. But 3, 3, when they match, they only show up once on this diagonal. So there is 1 out of 36 chances. Done. What's the chance that the sum is 7? Well, I can see that this is 7. These don't qualify. Then if I go to the second row, I get this to be 7. And if I go to the third row, this becomes 7. That's the sum of 7, 7, 7. So what I'm noticing is all these pairs that show up on this diagonal. Isn't that true? And how many are there? 1, 2, 3, 4, 5, 6, of course. Are you with me? So there are 6 out of 36 chances, which is also 1/6. Now, what's the probability that the sum, it doesn't matter what the order, right? It just says the sum, x plus y, y plus x, nobody cares. The sum is, I think, did I make a mistake here? Give me 1 second. No, I thought I made a mistake. Okay. So what's the probability that the sum is less or equal to 5? Well, here is 5. This is too little. This is too much, right? That's a 5. But I want less or equal to 5. So that qualifies. That qualifies, right? I'm going to actually circle them because I'm not going to need this box anymore. So that's less or equal to 5, less or equal to 5, less or equal to 5, less or equal to 5. I go to the second row. See how systematic I work with either rows or columns. That is 5, because I said less or equal to 5. So 5 qualifies. This is already 6, too much. Too much. So that's 5. That's less than 5. That's less than 5. Then I go to the third row. This third row. And I get this one and this one. Notice, this one and this one. And then I go to the fourth row and I only get this one. As I move down the rows, the number shrinks. You have 4 options here. 1, 2, 3, 4. Then you have 3 options. Then you have 2 options. Then you have 1 option. Did you see that all the rest are more than 5? That's 6, 6, 7, 8. So none of these qualify. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 options. That's what I got here. So I got 10 out of 36. Feel free to write this as a decimal. See, they're not hard if you think of creating a 6 by 6 table. Okay? So I'm going to give you an assignment based on this problem. You're rolling 2 dice. They're both fair. They're both numbered 1 through 6. And I already gave you the sample space. You can copy it from here or copy all of them. Actually, if you want to write all of them, that's how it works. So you already know your sample space. And now I would like you to do these 5 questions. It shouldn't take you more than 5-10 minutes. I want the probability that the difference between x and y is 3. I said x minus y. I did not say y minus x. The sum is odd. So for example, this qualifies because the sum is 5. This does not qualify. This does not qualify. That sum is 6. That's odd. Even, odd, even, odd, even, odd. You could probably guess what the number is going to be, okay? This one, the probability that x minus y in absolute value is 3. In other words, whether you have x minus y or you have y minus x, when you put them in bars, you're going to get the same value. For example, 5 minus 3 and 3 minus 5 are not the same, right? 5 minus 3 is 2, and 3 minus 5 is negative 2. But when I put bars around them, they both give me 2. What I'm trying to say here is, it doesn't matter whether you say x minus y or you say y minus x. You want the difference to be 3. Unlike this one, okay? So, have fun with this one. The next one, I want x to be fixed, to be 2. and y to be greater or equal to 3. So this one is actually easy. You get fixated on x equal 2. In other words, you only look at this row. Find out of this row which one has a y greater or equal to 3. So this is really silly. This is a little hard. Finally, I want x to be a prime number and y to be even. Now, you know what that means. Y is even. Let me just, I know you know that what a prime number is, but there are some misconceptions about being prime. So let me write a couple of things here for you, okay? So prime numbers are numbers that are only divisible by 1 and by themselves. And you might say, well, Mr. Alam, are you now insulting my intelligence? I know that. I know you know that. But just bear with me. 1 divides itself, and 1 is also divisible by itself, by 1. Divisible by 1. Just like 7 divides itself, and 7 is divisible by 1, by 1 only. 7 is divisible by 1 only. Therefore, 7 qualifies to be a prime. And 5 is a prime, and 13 is a prime. They're not divisible by other numbers other than by 1 and by themselves. 1 qualifies, doesn't it? Because 1 is divisible by 1, and 1 divides itself. However, we exclude 1 from being a prime. So 1 is not a prime. So a lot of kids think that 1 is a prime. It is not a prime, okay? And we exclude 1 from being a prime even though it fulfills the definition for a different reason. It has something to do with what we call the unique prime factorization. And what it means is any number, like 10, can be written as the product of primes in a unique way. So if we allow 1 to be a prime, I can write 10 like this, but I can also write it like this. So now it's no longer unique. So it's called the prime factorization, that every composite number can be written as the products of primes in a very unique way. 18 can be written as 2 times 3 times 3. Prime, prime, prime. And there is no other way to write 18 using primes other than these primes. But if we let 1 be a prime, you could write it like this. You could write it like this. You could write it like this. Right? So we exclude 1 from being a prime. So that's the first comment I want to make. 1 is not a prime. Okay? Keep that in mind. The second reason, the second thing I want to mention, to you is obviously not all odd numbers are prime, like 15 is not prime. However, all even numbers are not prime, right? Like 4 is not prime, 6 is not prime, 8 is not prime. All even numbers are not prime, with the exception of 2. 2 is even, yet 2 is not a prime. Okay? So this is the only even number that is not prime. So keep this in mind and keep this in mind, and then go back and do this problem. You want x to be a prime, which means a 2 or a 3 or a 5. I just gave it to you, okay? 2 or a 3 or a 5. And y is even. So now it becomes an easy problem. Finally, since you guys are having fun with those brain teasers, I get some really cute answers. I'm giving you one of them only. So 2 fathers and 2 sons caught 3 fish. So 2 fathers and 2 sons caught 3 fish. It looks like it's not enough, right? How can they share the fish equally without cutting the fish. In other words, you cannot take a fish and cut it in 3 parts or a half or something. You have to keep the fish intact. You cannot cut the fish. How could 2 fathers and 2 sons share 3 fish equally without cutting the fish? So that's that is your brain teaser. I'm gonna conclude with I should give you the answer to the brain teasers. What did I give you? Oh yeah, now I remember. Let me erase this. I remember one of them. I said, how could you... Oh, now I remember both. The first one is, what can you always find in the middle of a taxi cab? Some of you got it. So, again, here is taxi cab. You will always find I. Okay, so that's the answer to the first question. The second question, some of you got this one, which is awesome. Now, so far, I know a couple of students haven't submitted their assignments yet, but it's actually Friday night right now. But so far, none of you has given me the answer. So you cannot just remove a digits and throw it in the trash. I said move the digits somewhere, either a 6 or a 2 or a 6 or a 3 or a 1, but moving the 1 is silly because you'll end up, you won't even have an equation. You'll just have equal and blank, right? If you move the 1 somewhere else. So here is the trick. Are you ready? Ready for it? All right, watch. I'm going to leave 63 alone. I'm going to leave 1 alone. I'm going to leave the 2 alone. And I'm going to move this 6. And I am going to put it right there. 2 to the 6th is actually 64, isn't it? All right. Now, I could have asked the question differently. I could have said, how can you subtract 62 from 63 and get -1? Same trick. You leave the 63 alone. You leave the -1 alone. You leave the 2 alone with the minus, of course. And this 6 here, you put it right there. And now you have 63 minus 64 equals -1. All right? And in here you have 64 minus 63 equals 1. All right? You can, by the way, do this with 2 different numbers. Let me see. Yeah, you could do it with this one. 102 minus 101. How could you make it -1, right? So you take this 2 and you put it in the exponents. And now it works. You can flip it. How can you do 101 minus 102 and get 1? Because we know the answer is -1. How could you get 1? Same trick. 101 minus 10 and move this 2 here. So now you get 101 minus 100, which is 1. Okay? So you could do it in, this is 100 minus 101 equals -1. Okay? So you could do it with 62 and 63. You can also do it with 101 and 102. So I hope you enjoyed those 2 brain teasers. Now you know what kind of questions I'm asking you. You don't have to do serious mathematics like I asked you to find the next term in the sequence. Some of you are doing so much math. I'm going to multiply by 4, subtract 3, put the 1 here. You've got to think outside of the box. Just don't flatten the box though. Okay, some people think too much outside of the box. All right, so that should end this video. It's very nice and short. Your homework should take you like 5-10 minutes, and this entire video is about 24 minutes. All right, have a good one.